Today we discuss the chapter Matter. When we look around, we find ourselves surrounded by a lot of things. We can touch things like trees and cannot touch things like air. All these things have different properties and are different from each other. However, they all have one common thing. They are all made up of matter. Matter is anything that occupies space and has mass. All substances, whether living or non-living, are composed of matter. Everything in the universe is composed of matter. Matter is composed of extremely small particles and it exists in both natural and man-made states. In this chapter, we will study about matter in detail. Properties of matter. The food we eat, the water we drink, and the air we breathe are matter. So, what isn't matter? Anything that does not have mass and occupy space is not matter. Our feelings, heat, and light are not matter. Now, let's study the properties of matter. Matter has mass. Mass is the quantity of matter contained in a substance. More is the amount of matter in an object, more would be its mass. So let's perform the following activities to observe that matter has mass. So to observe matter has mass, let's take two balloons, a long thread, a meter scale, and a needle. Now we take two balloons, we blow air in the balloons and tie their ends with long threads of equal lengths. We take a meter scale and suspend the balloons at its two ends. We make a loop with the thread at the center of the scale and balance the scale as shown in the figure given alongside. Now we prick one of the balloons with a needle. Now we will observe that the balloon that is pricked bursts and the meter scale tilts towards the inflated balloon. Now we can conclude that this happens because of the mass of air present in the balloon. The balloon which contains air is heavier than the deflated balloon. This confirms that matter, here air, has mass. To show that matter has mass, let's do another experiment. A can, water, a spring balance, and a cotton thread are all that are needed. We suspend a spring balance from a hook. We make sure that the reading of the pointer should read 0. Then we tie an empty can to a strong cotton thread to form a suspension loop. We suspend the can from the hook of the spring balance. Now, note the reading of the pointer. Now fill the can with some water. Note the reading of the pointer again. The spring balance with the can having water shows more reading. This is because the can with water is heavier than the empty can. This shows that matter, here water, has mass. Matter occupies space. It means that the particles of matter move around in the space that they occupy. When we blow air into a balloon, its shape and size changes. This shows that air, matter, occupies space. Now let's perform an activity to observe that matter occupies space. We need a water, a tumbler, sand, and a spoon. Now take a glass tumbler and fill it with water. Mark the level of water on the outer surface of the glass tumbler. Now add 5 spoons of sand into the glass tumbler. Again, mark the level of water in the glass tumbler. Compare the two marks. You will observe that the sand settles down and the level of water increases. We can conclude the sand added into the glass tumbler occupies space. Therefore, the level of water increases and shows that matter occupies space. Now, what are the differences between mass and weight? Mass is the amount of matter in an object. Weight is the force of gravity acting on a mass. Mass is constant everywhere. Weight varies from place to place. Mass cannot be 0. Weight can be 0 if no gravity acts on the object, as in outer space. Now let's talk about the composition of matter. We have learned that all substances are made of matter. Let's now understand what matter is made of. Matter is made of very tiny particles called atoms. An atom usually does not exist independently. An atom is the smallest possible unit of matter that exhibits all its properties. The atoms combine to form molecules. A molecule is the smallest particle of matter. It has an independent existence and also exhibits all the properties of matter. A molecule is made of atoms of one kind or two or more kinds. Gases like oxygen and nitrogen are made of the same types of atoms. Like two oxygen atoms will together form an oxygen molecule. A compound like H2O, which is water, is made of two types of atoms, that is hydrogen and oxygen. In water, we have two hydrogen atoms and one oxygen atom. States of matter. All substances are made of molecules. The way these molecules are held together determines their state of matter. Matter exists in three states: solid, liquid, and gas. These three states are different because the molecules present in them are arranged in different ways. The molecular arrangement in different states of matter is such that there is always some space between the molecules. Now, this space between the molecules is known as the interparticle or intermolecular space. Also, the molecules are very small and it cannot be seen even under the microscope. These molecules attract each other with a force called intermolecular force of attraction. The force of attraction between particles of the same kind is known as cohesive force. The intermolecular force of attraction and the intermolecular space are responsible for determining the state of matter. The intermolecular force of attraction decreases as the intermolecular space between the molecules increases. Now think about it. In case of solids, the molecules are tightly packed. As the space between the molecules is very less, the attraction between the molecules increases. Hence, intermolecular force between the molecules of a solid increases as the intermolecular space decreases. Now, what do you think will be the relationship between intermolecular space and intermolecular force in case of gases? At ordinary temperatures and pressure, matter exists in three states based on the arrangement of particles or molecules. They are solid, liquid, and gas. Now let's talk about solids first. If you observe the following objects carefully, like spoon, ruler, and wood, you will see that all these objects are solids. So let us learn about the properties of solids. Solids have a definite shape, mass, and volume. The molecules in solids are tightly packed and cannot be moved. Solids like rock and table do not change shape. However, some solids like rubber can change their shape when an external force is applied to them. Once the force is removed, rubber returns to its original shape. Solids have high density. Density of a substance is the amount of matter contained per unit volume. Since the particles in solids are closely packed, they possess high density. Solids do not diffuse. Diffusion refers to the intermixing of particles of different substances on their own. Solids have strong forces of attraction and so the molecules do not move away from each other. Therefore, solids do not undergo diffusion. Solids are incompressible. In solids, molecules are closely packed together and the intermolecular forces are the strongest. Therefore, solids are firm, compact, and almost incompressible. The molecules in solids only vibrate about their respective fixed positions. Now let's perform the following activities to observe that solids have definite shape and volume. You would need a sheet of paper, notebook, pen, pencil, stone, wooden scale, and key ring. Now you collect objects like notebook, pen, pencil, stone, wooden scale, and key ring and draw their outline on a sheet of paper. Take these objects one by one and compress them gently without breaking them. Put the objects back in their outlines. You will observe that the objects fit in their outlines. This implies there is no change in the shape of these objects after compression. This shows that solids have a definite shape. Now let's talk about liquids. Now observe the following objects carefully: milk, juice, and water. All these objects are liquids. So let us learn about the properties of liquids. Liquids have no fixed shape but a definite volume. They take up the shape of the container they are stored in. Liquids have a tendency to flow. Liquids are free-flowing because the molecules are loosely packed. The increased molecular space reduces the force between the molecules. The intermolecular forces are not strong enough to hold the molecules of liquid at fixed positions. Hence, the molecules move freely within the liquid. Milk, fruit, juice, petrol, and water are examples of liquids. Liquids have less density than solids. Since the particles in liquids have more intermolecular space between them, they have less density as compared to solids. Liquids can diffuse. The intermolecular force of attraction is weaker in liquids as compared to solids. Due to this reason, the particles in liquids can diffuse and mix with other liquids. For example, if a drop of dye is added to a glass of water, it gets evenly distributed throughout the liquid. Liquids cannot be compressed. The volume of a liquid does not change much with the forces of compression. They may compress slightly under very high pressures. So let's perform an activity to observe that liquids have a definite volume but no fixed shape. You would need a measuring cylinder, a glass, a cup, a glass bowl, and water. Take 100 milliliters of water using a measuring cylinder. Pour the water in a glass and observe its shape. Then transfer this water to a cup. Observe its shape. Finally, pour water from the cup to a bowl. Again, observe its shape. Measure the volume of water using the measuring cylinder. You will observe that when water is poured in a glass, it takes the shape of the glass. When it is poured into a cup, it takes the shape of the cup. And when it is poured into a bowl, it takes the shape of the bowl. We can conclude that this shows that liquids do not have a definite shape. When the volume of water is measured using a measuring cylinder, it is found to be the same, that is 100 ml. This shows that liquids have a definite volume but no fixed shape. Gases. When you blow air into a balloon, the size of the balloon increases because air starts occupying space. Air is a mixture of gases. So let's learn about the properties of gases. Gases neither have a definite shape nor a definite volume. You must have observed that when you pump air in a bicycle tire or a football, air takes the shape of the tire or football. Oxygen, carbon dioxide, nitrogen, sulfur dioxide, and nitrogen oxide are all gases. Gases have maximum capacity to flow or fluidity. In gases, molecules are loosely packed. The intermolecular space is very large since intermolecular forces are weak. As a result, the molecules arrange themselves in a manner to allow movement in all directions. They move around independent of each other in the entire space available to them. Gases have very low density. This is because the intermolecular space between the molecules in gases is very large. Gases diffuse rapidly. The particles in gases move rapidly in all directions. This results in the diffusion of particles in a gas into the space between the particles of another gas. For example, the fragrance of perfume, when it is sprayed in one part of the room, spreads in the entire room. Gases are highly compressible. They can be compressed easily as compared to solids and liquids, as their molecules are loosely packed. Let's perform an activity to compare the compressibility of solids, liquids, and gases. To show that gases can be compressed easily whereas solids and liquids cannot be compressed. So we will To show that gases can be compressed easily whereas solids cannot be compressed and liquids can be compressed a little, we need 320 milliliter syringes, 3 rubber corks, water and flour or sand. We take the 320 ml syringes, block their nozzles with rubber corks as shown in the figure. Remove the pistons from the syringes. Leave the first syringe empty. Fill water in the second syringe and wheat flour or sand in the third syringe. Insert the pistons back in the syringes. Try to compress the contents of the syringes by pushing the piston in each syringe. You will observe that the piston could be pushed easily in the first syringe, which was empty because it contained air. The piston of the second syringe, which contained water, moved in a little on applying the pressure. The piston of the third syringe, containing solid, did not move in at all. We can therefore conclude that gases are highly compressible, liquids are only slightly compressible, and solids cannot be compressed at all. Now let's recall the properties of solids, liquids, and gases, then complete the table to distinguish between the three states of matter. Let's pause for a moment and review this particular table. So what is the explanation for the existence of three states of matter? In solids, the molecules are closely packed. The force of attraction between the molecules is very strong and the space between them is very small. As a result, the molecules are not able to move freely. They vibrate about their mean positions. It is due to this reason that solids are hard and incompressible and thus have a definite shape and size. For liquids, the molecules are not very closely packed in liquids. They do not have strong intermolecular forces of attraction. As a result, the intermolecular spaces are comparatively larger that allow the molecules to move freely. This makes the liquid flow and take the shape of the container into which it is poured. Thus, liquids have a definite volume but no definite shape. Gases. The molecules lie far apart and hardly attract each other in gases. Therefore, the molecular spaces are very large. The molecules move rapidly as the intermolecular forces of attraction is very weak. As a result, gases neither have a definite shape nor a fixed volume. The gases can be compressed easily. Now, reasons for the differences in properties of the three states of matter. The difference in properties of the states of matter is due to the following factors: intermolecular space, cohesive forces or intermolecular forces, random motions of particles. Intermolecular space. Intermolecular space is the space between the particles of matter. This space is almost negligible in solids and is very high in gases. The cohesive forces or intermolecular forces. Cohesive forces are the intermolecular forces or the attractive forces that exist between molecules of the same substance. The cohesive forces in solids are strong. Some liquids such as mercury also possess strong cohesive forces. Robert Brown, a Scottish botanist, discovered the random movement of particles. The zigzag motion or random motion of particles is known as the Brownian motion. The random motion of particles induces diffusion and Brownian motion. So what is diffusion? The phenomenon of intermixing of substances by the natural movement of their particles is called diffusion. In gases, the particles in gases have enough space between them that allows them to move freely. Hence, gases diffuse very fast. Liquids. Liquids also diffuse but not as fast as gases. Liquids are of two types: miscible and immiscible. Liquids like milk and water, which mix with each other, are called miscible liquids. Some liquids like oil and water do not mix together and are called immiscible liquids. Thus, all liquids do not intermix with each other. Solids. Solids are very rigid and hence do not diffuse under normal conditions or diffuse to a very little extent. Now, do you know that a leak in the gas cylinder can be detected due to diffusion of LPG in the air? Blue-colored ink diffuses in water, as a result of which the water turns blue. Brownian motion. Brownian motion refers to the zigzag movement of small particles suspended in a medium. This movement of particles is caused by the collision of molecules. Brownian motion can be observed by suspending some lycopodium or rubber powder in a beaker that is half filled with water. Using a microscope, it can be seen that particles of lycopodium move randomly throughout water. The movement of the particles increases further on heating the beaker. Effects of heat on matter. When heat is supplied to a substance, it goes through various changes. Changes in states of matter, thermal expansion, chemical change. Let's learn about these changes in detail. Change in state of matter. Matter can be changed from one state to another by supplying or removing heat energy. On heating, the molecules of matter move rapidly. Due to their continuous movement, they change from one state to another. All three states of matter are interconvertible. So let's understand this using water as an example. Water is liquid at room temperature, but it changes to ice on cooling. When water is heated, it changes to vapor or steam. Similarly, steam on cooling changes back to liquid. Ice kept at room temperature for 5 to 10 minutes changes to water or liquid. However, the properties of water remain the same in all the three states. So, ice on heating will become water, water on heating will become water vapor or steam. Water vapor on cooling will become water liquid, and water, which is liquid, on cooling will become ice. Water cycle is another example of change of state of water. Water cycle is the continuous circulation of water between land, atmosphere, and water bodies. Water cycle clearly shows that matter can be converted from one state to another and back to its original state without any change in its chemical composition. Pause this video for a moment and take a look at the water cycle diagram. To observe change in state of matter by making some mango or orange popsicles. Now all you need is a bowl having juice, a popsicle stand or mold, and a refrigerator. Take some juice, mango or orange, in a bowl. It is a liquid at room temperature. Now fill the popsicle stand or mold with the juice and place it in the freezer of the refrigerator. Take it out after 4 or 5 hours. The juice solidifies and turns into popsicles. The temperature in the freezer is lower than the room temperature. This shows that lowering in temperature causes the change in state of matter, that is from liquid juice to solid popsicles. Also, we can say that the change in temperature results in the change in state of matter. Similarly, change in pressure also brings about a change in the state of matter. LPG is a gas under normal conditions, but it is converted to liquid state at high pressure, which is present in LPG cylinders or cooking gas. Oxygen contained in oxygen cylinders used by patients in hospitals also contain oxygen in liquid state. Now, change of a solid to a liquid. This process is known as melting. We have learned that the molecules of a solid vibrate about their respective fixed positions. When ice is kept at room temperature, it gains heat energy from its surroundings. On gaining heat energy, the molecules start moving faster. After some time, a stage is reached where the energy gained by the molecules overcomes the intermolecular forces. Then the molecules break free and begin to move around even faster. At this stage, ice changes into water. This process of conversion of a solid into its liquid is known as melting. Melting point. The entire conversion process occurs at a constant temperature. The constant temperature at which a solid changes into a liquid is called its melting point. The melting point of a solid is a measure of the strength of the intermolecular forces. Change of a liquid to a solid. Freezing or solidification. When water is kept in a freezer, it loses heat. Due to loss of heat, the energy of molecules decreases. Their movement slows down and they come closer to one another. In some time, a stage is reached when the movement of molecules becomes so slow that water changes into ice. This process of conversion of a liquid into a solid is called freezing or solidification. Now, you must know that the numerical value of melting point of ice and freezing point of water is the same. It is 0 degree centigrade. Freezing point. Freezing or solidification occurs at a constant temperature. The constant temperature at which a liquid changes into a solid is called its freezing point. Change of a liquid to a gas. Vaporization. The process by which a liquid changes into its gaseous or vapor state is called vaporization. Vaporization is of two types, evaporation and boiling. Evaporation. Evaporation occurs at all temperatures. During evaporation, the molecules on surface of a liquid gains heat energy from their surroundings and change into vapor state. When water, the liquid, gains heat energy, it changes into water vapor or steam, which is gas. Boiling. When water is heated, its molecules gain heat energy and start moving away from each other. As the temperature increases, a stage is reached when the molecules gain so much energy that they leave the surface and change into water vapor or steam, which is gas. This process of change of a liquid to its gaseous state on heating is called boiling. Boiling point. Similar to melting and freezing, boiling also occurs at a constant temperature. The constant temperature at which a liquid changes into a gas is called its boiling point. The boiling point of water is 100 degrees Celsius. Let's pause for a moment and look at the definitions at the bottom of this page. So this table states the difference between evaporation and boiling. So boiling occurs at a given temperature called boiling point of the liquid. Evaporation takes place at all temperatures lower than the boiling point of the liquid. Boiling is a rapid process. Evaporation is a slow process. Boiling occurs throughout the liquid. Evaporation takes place only from the surface of the liquid. In boiling, there is no cooling caused. In evaporation, cooling is caused during evaporation. Boiling occurs only when the liquid is heated. Evaporation takes place on its own. Now, this is the difference between evaporation and boiling. Now, a substance that exists in the gaseous state under normal conditions of temperature and pressure is called a gas. For example, oxygen, hydrogen, and nitrogen are some gases. A substance that exists as a solid or liquid under normal conditions of temperature and pressure but changes to its gaseous state under specific conditions is called vapor. For example, water vapor is the gaseous state of water. Similarly, iodine vapor is the gaseous state of iodine. Change of a gas to a liquid by condensation. When a gas is cooled, it condenses to form liquid. This process is called condensation. When a gas is cooled, its molecules lose energy. On losing energy, their movement slows down. After some time, a stage is reached when the movement of molecules becomes so slow that they change into the liquid state. Condensation point. This entire conversion process also occurs at a constant temperature. So, the constant temperature at which a gas changes into a liquid is called the condensation point. The numerical value of boiling point and condensation point of a substance is the same. The condensation point of water vapor is 100 degrees centigrade. Change of a solid to a gas. Sublimation. Some solids like iodine, ammonium chloride, camphor, naphthalene, benzoic acid, mercury chloride, and solid carbon dioxide, which is dry ice, on heating directly change into gaseous state without changing into a liquid. This process is called sublimation. A direct change of state from a gas to a solid is called deposition. The solid obtained on cooling the vapor is called a sublimate. The gaseous state of a solid is called sublime. Naphthalene balls or mothballs are placed in cupboards between woolen clothes to keep insects away. This is because naphthalene sublimes into vapor at room temperature, which drives away the insects. Thus, with passage of time, the size of a naphthalene ball decreases. Expansion of matter. All the three states of matter, solid, liquid, and gas, expand on heating. On heating a solid, the particles gain energy and vibrate more vigorously about their respective fixed positions, forcing each other further apart. This results in expansion of a solid. Similarly, the particles in liquid or gas, on gaining energy, are forced further apart, causing expansion. The degree of expansion depends on the substance. A liquid on heating will expand more than a solid. Gases expand enormously when heated. Let's perform some activities to understand expansion of matter. To show that a solid expands on heating and contracts on cooling, the materials required are a metal ball, a metal ring, a burner, and an iron stand. So we take the metal ball and a metallic ring. Try to pass the ball through a metallic ring. You will see that the ball passes through the ring. Now heat the metal ball for 5 to 6 minutes. Try to pass the metal ball again through the metallic ring. You will see that the ball cannot pass through the ring. We can conclude that expansion occurs on heating a solid. When we cool the ball, it will pass through the ring again. This shows that solids contract on cooling. To show that a liquid expands on heating and contracts on cooling, we need colored water, a cork, a capillary tube, a round bottom flask, and a burner. Now take a round bottom flask and fill it with colored water. Close the mouth of the flask using a cork. Fix the capillary glass tube through the hole in the cork. The tube should be dipped in the water. Check and note the water level in the capillary tube. Now heat the flask by placing it over a burner. You will notice that the level of the colored water rises in the capillary tube. This shows that expansion of a liquid takes place on heating. On further cooling the flask, the level of water in the capillary tube decreases, which shows that liquids contracts on cooling. A chemical change on heating. A chemical change is a change in which new substances are formed. It is a permanent change. The properties of newly formed substances are entirely different from those of the original substances. A chemical change can be caused by heating a substance. For example, when we burn a piece of paper, it changes into ash, which is a new substance. The properties of ash are different from those of the paper. We cannot change ash to paper. This shows that burning of paper causes a chemical change. Similarly, burning of a candle is also a chemical change. When we heat a candle, candle wax melts and then changes into vapor. This vapor reacts with air and forms two new substances including carbon dioxide and water vapor. So burning of a candle is a physical change going to candle wax, but candle wax undergoes a chemical change to form carbon dioxide and water vapor. Hence, we observe that the candle becomes smaller and smaller on burning, and the recovery of the part of wax which has undergone chemical change cannot take place.